Hi, Julian here from PopcornFX. Today we will see how to use the VectorField sampler in PopcornFX, and I will create a simple effect to show that. So I'll start with an empty effect. And when I create effects, I always like to start first with something that I can see in the viewport. So here I just create a simple billboard render. I hit Ctrl R to reset, and at least I see something. I have a particle on screen, and I can then proceed to build around that, adding nodes and seeing how it affects what I have. So here we have a single particle, so I will add a multiplier node to have a bunch of them instead of just a single one. So here, as soon as I want to see what the effect does, I have to hit Ctrl R as it stops after 1 second, because my particles just live 1 second. So you have multiple ways to change this. So you could either enable the loop mode here, so it's on by default but with a delay of 0, so it's as if it were disabled. And here it will loop every 3 seconds. If you set that to 1, every second it will restart the effect. You can see down there in the timeline the little cursors that show where the previous instances were, so I can scrub that timeline. I'll keep it at 3 seconds. And I will, let's say, change that VRAND, add some drag, and here you can see a kind of weird double sphere. Well, that's because I have the collision node here. So the particles spawn at the origin and they immediately bounce off because of the collision node. That's just because I used a rig. Instead of dropping all those nodes, I use the physics rig, which includes also the collision node. That's why I have it here, so I'll just delete that. Yeah, and now you can see that the particles go below the grid. So I will scale that velocity to make it go a bit faster. Now, because I have the drag in the physics node, the particles start fast and then they decelerate because of the drag. Now, the interesting thing here is that they don't just decelerate, they actually accelerate towards the current wind value of the physics node, which is 0, so it's basically as if they were decelerating. But here, if I change that and make the wind go upwards, you will see that without drag they just go in a straight line, and as I increase the drag they will slowly match the wind direction, and the higher the drag, the faster they go along the wind direction. So I'll just keep that at 2. So now that I have drag and this wind, this is where I can use a vector field, because the vector field will basically modify the ambient wind used by the physics node. So here I have a single value, but using the vector field basically gives me position dependent wind. So here I will click on this little eye icon here to expose the vector field as a pin. And actually, before that, I'm going to show you just picking a vector field asset. So I will increase the scale here. So now they all go down for some reason. That might be, yeah, that's because the vector field is actually quite large. Yeah, you can see it better here if so I'm pressing space here. So as I spawn those particles, you see them going around the vector field, and if I open that, yeah, so you can see here that the grid, this should be the same scale as the grid here, and that vector field is pretty large, and you see them here going around those vortices. So that's one way to use the vector field, just pick an external vector field. But if you click on this eye icon, you will see the vector field property being exposed as a pin, which you can then drag. And so you don't type vector field. You have to type turbulence, or apparently it also matches. Yeah, it also matches the turbulence node if you type vector field, but it will appear last, so you can just type turbulence. It's quicker. So the turbulence node is it's basically a legacy name, because that's the name we had for vector fields in version 1 of Popcorn, and we kept that same name for this node. And like other resource nodes, such as the shape node or the texture node, these nodes just define a resource. You can see that as resources. So here we define a vector field resource, which by default is set to procedural. So this, when you set it to procedural, this is basically a curl noise vector field. So it's a random wispy looking vector field that looks like a turbulent wind. So here you can see all those particles flocking around and following that turbulence. So you have a bunch of controls. The global scale makes the wisps larger. The strength makes the field be stronger, so the particles will go faster along the field. And the rest is basically just details to tweak the turbulence. We don't really care about these right now. And on that drop down, set to procedural, if you pick external, you will get the same thing as when we picked the external vector field file directly in the physics. So here you can pick an FGA file and use that as the vector field. Right. So that's probably the easiest way to go around using vector fields. But often you don't just want the particles to follow the field without any more controls. So you might want to fade the intensity of the vector field as time goes by. And to do that, you might be tempted to try to expose this strength attribute here, the strength property, in the graph, but you see that there is no eye icon here. So these are, as I was saying, those nodes are resource nodes, and these are static values. It's pretty much a shortcut to creating an FGA file, having that static file on disk, and that's it. It's an immutable thing. You can't change it dynamically. So all these cannot be exposed to the graph. So for any property where you don't see the little eye icon, it's a property that's totally static, and you can't wire a computation to evaluate it. So instead of that, if you look at the physics, we have that vector field scale value here. So changing this, here I've put 5 instead of 1. It's exactly the same as if here I had multiplied that strength by 5. it gives me the same result, except that by using that value here, I can expose it into the graph and I can control the strength of the vector field with whatever method I want. So here I'll just drop a curve sample, and if I open that curve, so here it starts not being strong and it ends at full strength, and by default it's using the life ratio of the particle to sample the curve. So I'll leave it at that. The life ratio is basically a 0-1 value. It's 0 when the particle is born and 1 when it dies at the end of its life. So here, if so if I do it the other way around, so it starts high, put it back to 5, and then it ends at 0, you can see now that the particles start being turbulent and then they stop being turbulent at the end. That's just because here we are scaling down the intensity of the vector field. I can make this a bit more dramatic. Yeah, that looks fine. So these curves by default are between 0 and 1, and that's fine when you're using it with the life ratio. You might want to use instead the particle age or the effect age. So here, let's say I use the particle age. So because my particles are living 3 seconds, here by default it's repeating the curve. So you can see that the curve will start being strong again 3 times every time it repeats. So I can either disable the repeat, it will just stop there. You can also rescale that time range. So here the curve is still between 0 and 1, but by changing that cursor range, we're basically saying, well, no, that's between 0 and 2 actually. So when my curve is at 1, it will actually be at time 2 seconds. And if I put it to 3, it will do the same thing as if I had chosen life ratio, because my particles are living for 3 seconds. The good thing with life ratio is that you can rescale the particle age without having to go back and retweak all the timings in your different curves. So in that case, I'll stick with age, but I'll show you a neat thing in 2.6, in PopcornFX 2.6, that allows you to remove the 0-1 limit of the curves, because here you can't move the control points outside of the 0-1 range. So now you have that has time bounds property that you can uncheck, and if you uncheck it, now you can actually move that beyond the 0 to 1 limit. So I'm actually going to set that to time 3 seconds. And set it to 0. Right, so now I can do things like fade this off quickly, and then have a little spike towards the end for whatever reason. Let's just say I like the look of it, where they start following the turbulence again for a short period of time. Okay, so let's say I'm happy with that. Now they all spawn on a point here because I didn't give any initial position. So I will sample a shape instead so you can see that they actually shoot in random directions. They spawn on that sphere, but they shoot all over the place. That's because we use a VRAN node, so that's a random point on sphere node. And this is totally uncorrelated from the position they spawn on that shape. So I can instead expose the shape normal here and use the shape normal as the initial velocity. And now they shoot in the correct direction. So just to make things more visible, I will quickly add a trail node so that we can actually see the paths they are taking. So to use a trail node, you just wire in a position and it will output an event. So to use that event, I need to export it back into the layer graph so I can wire a new layer in it. So here I just created an output node and wired that event signal link, signal wire inside. So now I have that pin here that I can use to wire into a new layer. So here, same thing again, I'm just creating a billboard node to directly see where things are. And you will see that everything spawns at the origin. That's just because I need a local to world node. So instead of a billboard, I'm actually going to use a ribbon. This will be nicer. Just gonna scale that down. Right. By the way, when I'm going back like this, I'm not clicking anywhere, but I'm just using a back and forward button on my mouse. That's why you're not seeing me clicking anywhere. So here, as I change the shape, let's say cylinder. Yeah, and I now have a much nicer view of the turbulence. And I will actually increase these a bit more. Just so it's more visible. And I will make it spawn more particles. Yep, that's better. Just add a 0 to the spawn count. Just for it to be a little bit less ugly, I will fade the color. So let's say oh yeah, this is fine. Simple and fine. Right. Yeah. So you will actually notice here on the trails that if I slow down time, that the trails, there's a gap between the leading particle, so the parent particle, and the child. And this is just because the resolution of the trail is pretty low. So I can fix that very easily simply by selecting the trail node and changing the spawn interval value. So this will just make the density of the trails higher and the gaps will be almost gone. Yep. So this is a bit uniform, and I'm going to change the color of the parents. Let's say something like this. And I will wire that into the child event so that the child particles can inherit the color. So I will add a payload append node. I'll append color, wire that in, and here it tells me that I am overriding a payload name color that already exists, and this is actually because the trail node allows you to wire in a color. So here you can hit Ctrl U on a node to just make all its inputs and outputs visible, and you can see that here I do have a color pin, so I'll just wire that in instead. And now if I go back, here it tells me that I have a color payload in the event link that nobody is using. Well, that's normal, I'm not using it yet. So here, to grab it in the childs, you'll need to drop a parent node, event parent, and to extract the color payload. So here you can either type color in here or use the drop down and pick color, and now I have my color. And you can see that the trails are now using the color which I specified in the parent. So I'll add a little bit of variation here, of hue variation. So this randomizes the hue slightly. So there is one nice trick you can use here to tweak things. If you click on the timeline and pause the effect at a spot you like, you can then go and tweak things and directly preview them. So that's pretty neat for colors. So now I don't have my fade based on time anymore. So to fade that, either I can hit Control Space on the wire or right click insert node, but usually hit Control Space, it's faster, and multiply the color with that curve, and we'll have our fade back. However, this also scales. This also scales the alpha values. And you might not want to scale the alpha values just to scale the intensity. For example, here if I have an intensity that's above 1, this will actually be pretty bad for the alpha. You usually don't want intensities above 1 for alpha. So to avoid that, I can use the color node again, and in the color node I have an RGB scale and alpha scale, and I'll just expose the RGB scale as a pin, wire my scale in, and that's it. Also, I'll quickly pick a different texture for the ribbon. I'm not sure if I have any good ones there. Oh yes. Great. So by the way, with the shape here, I can also spawn that on a mesh instead of a circle or sphere or whatever. But here I'm fine with the cylinder actually, so I'll keep that. Now the trails, when they end, they're pretty, the end is pretty sharp, so I want to fade the parents as well. So I'll expose the RGB scale and just use another curve. Something like that. Looks fine. And the nice thing here is that because I'm sending the color of the parent over to the child's, and that I'm using that, scaling it with the fade of the child, I actually get for free in the child's the fade of the parent. So that's it for this video. I hope it cleared up a bit how to use turbulence and vector fields in particle simulations in PopcornFX. Thanks for watching.